So thank you everyone for being here this afternoon, so late in the conference, sticking around and waiting for me, or I assume you're here for me. My name is Nathan Mitchell, and for the last, I don't know, 8 months or so, I've been working on a little feature called Scriptable Tools, which is sort of what this talk is about. In fact, it's actually a lot about this talk. I feel a little bad because we had to put in the talk titles way earlier, and it's going to be more Scriptable Tools than Geometry Script, but hopefully you'll stick with me and you're here for Scriptable Tools. And a little bit of Geometry Script, and some other stuff, because we have a lot to go through, and we'll see if I can get it all done. So, what are we going to be talking about today? We're going to be talking about Scriptable Tools, primarily the updates for 5.5. Who here in the audience has used Scriptable Tools before? Anybody? Couple hands, few hands. Okay, so mostly new people. Cool. So what are Scriptable Tools? Scriptable Tools, let me give you an example. Start off with a little bit of live demonstration here, because everyone always loves live demonstrations. So Scriptable Tools basically let you build your own interactive tools in the editor. They have their own little mode that you can put them in. They let you do really fun stuff like this light placement tool that reacts automatically to where the mouse is and what kind of position you're acting on. I'll zoom in here a little bit so you can see exactly what I'm talking about. Whereas we go from the floor to the wall, it transitions automatically to a different kind of actor, that sort of thing. And lets you, do things like decorate your level the way you want. They can do a lot more than that, and we're going to be covering a couple different things, a couple different example tools in this, this talk. But that's the general idea. So, exactly what are Scriptable Tools? Scriptable Tools are a blueprint-based system for developing your own interactive tools in the editor. And generally, what we're talking about here is a generic framework to build tools that is built on top of the ITF. So that's the Interactive Tools Framework. If you're not familiar with modeling mode, this is what all the tools in modeling mode are built off of under the hood in C++. Scriptable Tools takes that framework and exposes it up to you as a blueprint accessible system, so you can build tools that are very similar to what we're doing in modeling mode. The goal of Scriptable Tools is to primarily help you guys automate your functionality in the editor through blueprints. It lets you connect to any blueprints, whether it's system-provided blueprints in the editor or blueprints you write your own. You can all tie them together in Scriptable Tools to automate whatever you do inside your level creation process. I like to think of Scriptable Tools as sort of like your glue. This is your glue system to tie together disparate parts of the editor and bring it all together and make it a little bit faster, a little bit easier to work with, a little bit less manual effort. So let's talk about Scriptable Tools in 5.5. Scriptable Tools aren't new. The original Scriptable Tools was released for 5.4 as a beta plugin. And the work we've been doing for 5.5 is basically extending and expanding upon all the functionality that we had before. And to that end, I'm pretty excited to announce some of the new features. The first one that you're going to see that if you've worked with Scriptable Tools in the past will be the behavior system. So in the past, when you wanted to write a Scriptable tool, you would derive from some base class, like a click or a click drag base class, and that's what the tool did. It clicked on stuff, or it click and drag stuff, and that was it. The new system uses a new function-based API that lets you basically compose behaviors at will inside of your tool to do whatever you want. If you want to have clicking and hovering and clicking and dragging, or multi-clicking or keyboard interaction with your clicking, you can do all the things you want. And just sort of compose it on the fly as you're building your tool up. The next big feature we're adding is geometry visualization. In 5.4, there was support for basic rendering within the tool, but 5.5 brings around new renderable objects, such as lines, points, and triangles, that you can define and then manipulate over the lifetime of the tool's execution. As you'll see later in the talk, this will make things a lot easier to work with, especially for more complex tools. In a similar vein, we also have access to viewport widgets. This is a new feature that makes use of blueprint widgets that you may have used in other aspects of the editor. Only now we can actually embed those directly into the tool and have them show up in the viewport as a floating dialog, so you can design your own UX for your tool as you see fit. A couple of other features that are worth pointing out. Tool builders, this is going to be new for 5.5. Tool builders basically let you control the starting conditions of your tool, making sure it can only run when certain conditions are met, and or provide custom initialization data for your tool, which may be useful. And I will show an example of this later in the talk, where we talk about a concept I like to call like smart objects that you'll see interacting with the tool itself. And then finally, we also added a feature. This was requested actually by the Fortnite team for tool mode groups, or tool groups, sorry, where we're able to basically group and filter tools that show up in the mode palette to make it a little easier for large teams to manage huge collections of tools across different teams to do different things. It's also going to be really useful if you are looking to sell tools later on Fab, because you can actually group them under these groups and have a collection of tools that you can sell to a user without having to just show everything off in the palette at once if you don't want to. Okay, so with that sort of out of the way, I'm going to jump into some demos and show off what we can do with Scriptable tools. Let's see. I'm going to switch actually here to a starting level. Give me 1 second. All right, so for the purposes of this demo, I put together a little fantasy scenario. This is sort of a 2D dungeon. You might think of it as just like a RPG game or something to that effect. And what we want to do for this talk is use Scriptable tools to sort of populate and enhance this level and make it look extra cool. And we'll see how we can use the framework to automate some of the processes that are a little bit annoying when doing general game work. So let's get started here. The first thing I wanted to show off is actually how to actually turn on the plugin for those who haven't used Scriptable tools before, and sort of show a really light basic workflow through them. So the first thing we're going to take a look at is the plugin itself. So there are two primary plugins for Scriptable tools themselves. There's the editor mode and the framework. One depends on the other, so you'll get one turned on if you turn the other on, but they're both checked here. And you're also probably going to want geometry mode or geometry scripting, if I can type. Apologize for that. While it's not strictly required for Scriptable tools as a dependency, it's extremely useful to have it, as you'll see in various line testing parts of the tools. So we usually turn that on as well. Okay, so let's create a basic tool and take a look how this works. So tools start from a blueprint class. And what you're going to want is this new editor scriptable modular behavior tool. We actually have two different versions here, one with editor and one without. Editor is what you want if you're going to be using any editor-only blueprint routines in your tool. If you know you don't need any of those, then you can go with just Scriptable one. This is so if you want to write, for instance, runtime-based tools, you can. Just be aware that you won't have access to editor-only functions in runtime-based tools. So keep that in mind. So we're going to create an editor-based modular behavior tool. This is the new base class, by the way, for doing all the modular behavior work, as opposed to the older base classes that were single behavior only. So we'll just call this test tool. All right. Let's pop this open and take a look at what this looks like. So by default, you don't get a whole lot in the tool. There's a few things of note. On the side, you have a bunch of settings over here, such as the tool name, a long name that'll show up at the bottom, a category for the tool, a tooltip. You can give it a custom icon if you want. Fairly basic, straightforward stuff. There's also visible in the editor, which shows whether or not it's going to actually show up. And then some other things that we'll talk about here in a little bit. And over on the other side, you have sort of the core that you need to actually override. So probably the most likely functions you'll be overriding are setup and shutdown. Setup runs when the tool starts, and shutdown runs when the tool ends. The names are fairly self-explanatory. Generally, you want to do all of your basic setup type stuff, like setting up behaviors, setting up other types of long-lasting properties of the tool in your setup event, and then have everything else be event-driven from there on out. So let's say we want to make this a click behavior-based tool. So we can add a single click behavior. And you can see now that we have this new function that takes events. And this is basically going to let us develop an event-based tool that responds to clicks in the scene, like so. Every behavior is different. They all have their own events you have to override. Usually it follows a fairly straightforward process of, is a click going to be detected? What happens when the click is actually happening? Things of that sort. There's other behaviors like mouse hover and mouse scroll wheel that have their own appropriately named events as well. So let's just take a look at what it would take to write an if click. So we're going to create a matching function here. And you'll see it gives us some information, such as the world position, and it wants a return value. So the first thing we're going to do is we're going to break our array up here. This is actually a geometry script node. So this is one of those things that you kind of want geometry script for if you're writing Scriptable tools. It makes your life a lot easier to do that. And we're going to do a line trace. Okay. Like this. And that will tell us a bunch of things from a line trace. And we can use this to basically query our scene and figure out what's going on when you've clicked the mouse, if you're clicking on something specific, if you're clicking on something too far away, et cetera, et cetera. And you can use that to determine whether or not you want the tool to respond to this particular click event or not. Let's say that we do, and we're just going to create a array. What is it called? Now I'm array hit. There we go. Oh, no, and I clicked off. Oh no. There we go. Make array hit. So there's a number of these make array hit routines that you can use to determine what kind of array you're actually spitting back out. But we're just going to connect this up real quick, like so. And return a value here. So you can also use a make array hit miss if you want to return didn't hit anything, for instance. So if we didn't like what this was returning for whatever reason, we can return a miss and basically not return anything at all. And that's basically how it works. You do something similar for the on click as well, and then usually you would do some sort of action, spawn a mesh, or do whatever your tool is going to do. But in lieu of actually building this thing out altogether, I'm actually going to switch over to one of the tools I've already built for this demo, just to give you a slightly more realistic example of what a tool might work, and try and finish that out for us instead. So let's close this for a moment. And we're actually going to pull over this light placement tool. So this thing is the same as the light placement tool that I had before, this light tool over here. And it basically lets us move around the scene with our mouse and automatically place light objects depending on what you've selected over here on the side. So I can switch between fireplaces and wall sconces, and it's reactive to the normal on the wall, that sort of thing. So let's take a look at how to build one of these. So I've sort of put together a little skeleton of this, and we're going to fill out the behaviors this tool is going to want. So we're going to want a click behavior, because we're going to have to click the mouse. And we're also going to want a hover behavior, because we're going to want to move the mouse around, like so. Okay. So to speed things up, I've actually pre-created the functions we actually need here, but I'm just going to add them and go into a little detail on what they look like. So we have a hit test and a click on hit. And you can see this looks basically what I showed you before. I have this ray hitting wall test that I wrote earlier. And this is just a slightly more advanced version of that line trace with a bit of a normal test in there, just to see if you're actually hitting the floor or the wall. Okay, so nothing too fancy. And then the same for the click, except here we're actually going to do something. We're going to position the light on the wall, which sort of looks like this, depending on if you're on the wall or floor. And you're then going to spawn a new light instance. Except we have a small problem. Which light instance are we spawning? So we actually need to figure that out, and that's where the Scriptable tool has access to what we call a property set. So you can see here I'm pulling this variable called settings, which doesn't actually exist yet, but we'll be creating that in a second. So after we set up the behaviors, and we're going to do the same thing over here with the hover as well. So we have an hover update, like so. And over here, like so. Hover hit test and a hover update. And they look pretty similar to the mouse click, slightly different. The hover update, for instance, has a check-in to determine if you've switched between a wall and a floor, and it will change which object we actually want to spawn. So fairly straightforward. And then the last thing we need to actually worry about is a property set. So we're going to pull out this function, create property set, and take a look at that. So there. Property sets are what Scriptable tools use to basically handle user-controlled settings. So if you're used to modeling mode, you have the sort of details panel on the left-hand side of the screen. You can do the same thing in Scriptable tools via property sets. So you basically have a blueprint that looks like one of these. One second. And it just has a bunch of properties in it. In our case, we have light color. We have two classes that we're using for our wall placement. And we're just going to assign that to the tool over here with add property set of type, store it as the settings, and then we're going to do a little bit of binding to watch the light color. So as we change the light color in the scene, it'll update whatever object we've got moving around under our mouse cursor. And when you put it all together and you turn on the tool, because this was my test demo, what we'll see is a new tool in our Scriptable tools mode. Let me show all the tools, called Light Start. And it should do exactly what the other one did. Look at that. Follows the mouse, we can change the color and use this to populate our dungeon with all kinds of colorful fantasy lights with ease. Okay, so that's really cool. It's a fairly basic tool, nice and simple. Let's move on to something a little more advanced. And we'll try and look at the next stage of dungeon life, which is, of course, kicking down the doors, because everyone loves to kick down doors in dungeons and find out what horrible things are on the other side. So we need a door tool, and that's this tool over here that I wrote. And as you can see, as I'm dragging around these hallways, it's generating this door frame automatically. And more than that, as it goes into bigger hallways, it can actually generate bigger door frames automatically with the door placement in between. And if I was to click, it actually will insert a door in the door frame, like so, allowing us to bring our dungeon to life a little bit closer to reality. Okay, so let's take a look at how this tool works. Now this one I'm not going to build from scratch because it's a little bit more complicated, but as you'll see, it's not too much more complicated than the last one. So starting from the beginning, you see we have that same on script setup, and we have a mouse hover behavior and a mouse single click behavior, and a couple other supporting bits over here that we'll get to in a bit. It more or less works the same as the light placement tool. You're moving the mouse around, and it's testing to see if you are, in this case, hitting a passage. So here we have a little bit more complex ray testing, and I'll bring this over so you can take a look at this. I'm not going to go into this in great detail because the node graph is a little bit more complicated compared to the last one, but basically what we're doing is, given a point in space, we're saying, okay, do we have walls to our sides? Walls to our sides, which one is closer together than the other? And that's our passage. If it's within some distance, then it's a passage, otherwise it's a room and we ignore it. So pretty straightforward, even though the node graph is a little bit more hairy. So we get a bunch of information about our passage here. We move our actor, which is going to be a dynamic mesh actor, into the scene according to where the mouse is. And then we go over here and we generate some wall geometry. So let's take a look at this generate wall. And we can show off some geometry script here as we're working in a Scriptable tool. So we've got this wall actor that is just going to be a dynamic mesh in the scene. We clear out all of its existing geometry, and then we start working on actually constructing this wall piece by piece. So the first thing we do is we build ourselves a box, basic box, with the right dimensions, and then we cut ourselves a hole in the box, which is going to be this door punch. Well, we haven't talked about the door punch yet. That's another dynamic mesh that we constructed at the beginning of the tool over here at the end. Make door punch. And it's basically just doing a dynamic mesh on the fly at the beginning of the tool, where we're going to take a rectangle on the bottom, a cylinder on the top, and Boolean them together to make a sort of nice silhouetted around the top door. And we're just going to save that and hold on to it. And we'll use that over here in the wall generation to punch that object right out of the wall and make ourselves a nice door frame. Then we'll do some UV scaling to make it match the rest of the walls in the dungeon, set up some materials on that wall, and turn on collisions so players can't accidentally walk through the wall that we just created, because that would ruin the whole effect and make walls useless. And then if we go back and actually look at the click, it's going to do basically the same thing as the hover does, except it's going to have one last bit at the end where we spawn in a door actor. And this is a blueprint I created ahead of time that just has a basic skeletal mesh that makes the door swing back and forth as you get close to it, so nothing too fancy. And that's more or less all it does. It does react dynamically to the size of your passage, and it intelligently figures out how to place the wall geometry and put the door where it needs to go. And that's a combination of Scriptable tools and geometry script. Okay, how are we doing on time? We're doing pretty good. I'm probably going a little fast, so that's good. We'll have time for questions later. Okay, so the next thing, after we've got lights in our dungeon and doors in our dungeon, the next thing we need are monsters in our dungeon. Or, well, in our case, it's going to be some robotic-looking NPCs, because I don't have artistic skills to make monsters. I apologize for that. However, we do have some nice, cool features from Scriptable tools on this new guard placement tool. And you'll notice right away when the tool starts, we have this new floating widget, which is going to be the UX the tool is generating for us. And this UX is actually giving us a couple different things. It has 3 different guard modes. It has a stationary mode that I can use the mouse wheel to spin the guard around and place them into the scene. Let me zoom in here so you can see more clearly what's going on. I'll do that again. So that's convenient. We also have access to a route mode, which allows me to place a guard down and then draw out a path. And I can hit the D key and commit that into a spline that the guard will now follow. Or if I want to be really fancy, I can go over here and I can use the area mode and actually draw out a zone that I want the guard to patrol. And this actually hooks into the navigation mesh and provides an area that the guard will actually stay within instead of going anywhere at once. So as you can see, this is sort of a tool to make it a little bit easier to place your NPCs in the world with some automatic behaviors associated with them. So let's take a look at how this tool works. This is a more advanced tool than the last one, which means we're probably not going to go into as much detail as we would like to see in this 50-minute talk, but we'll do our best to look at the salient points. So right off the bat, you can see it has a lot more behaviors than the last one did. In fact, it's got 6 different behaviors, including this hover behavior at the beginning. But first, let's take a look at our UI, because that's the new piece of technology that we want to show off with this tool. So we have this setup UI function here at the beginning. And right away, we can see that we've got this create guard placer UI widget. This is not actually a Scriptable tools node. This came before with the blueprint widgets. And it takes in a blueprint class that we can take a look at. Let me just open that up here. So if you haven't used the widget designer within the editor, that's what this is. It's basically a way for you to design slate widgets dynamically in the editor itself without having to write any C++ code. You can lay it out with a nice to use GUI, and more importantly, you can mark various elements in your widget as variables. And we'll be using this in concert with the Scriptable tools node set overlay widget to basically attach this widget to the screen, to the viewport, as a floating dialog. And then all the variables can then be bound to within our Scriptable tool to trigger different events. In our case, we'll be using them to change the mode of the tool to basically switch between different behavior sets So we can either use the stationary or the route or the area mode, respectively. Let's go back to the event graph. So you can see over here we've got a number of different modes in the tool that have been grouped off by colors. We have a standing, we have the route, and we have the area mode. And all of these are using a little bit of code called a capture check down here at the bottom. And this is used by different behaviors basically to say, no, I don't want to see any events at all, or yes, please give me events. And this is sort of the raw event you get from the input router under the hood. And we're actually going to use this here in concert with the mode the tool is in to determine whether or not this entire set of events or the entire set of behaviors should be basically turned off or turned on during the tool's runtime. And that lets us basically prune out whole sections of the tool's code depending on what we actually want the tool to do at any one point. But the other important thing I wanted to point out here, the other major feature for 5.5 are the geometry visualizations. So the point, the line, and the triangle sets. So we can see down here at the bottom, we've got some line sets and a point set being created when the tool starts up. And those are actually being used when we are doing things like clicking with inside this event. You can see we have this add line segment node. And if we take a look at this node a little bit, it's a little messy. But you'll notice that we have options like adding points to our line set, or to our point set, sorry. And we can then reference that returned component and set its size, its position, etc., and store it over time as an actual variable within our inside of our tool. And that's what we're using over here with this current line preview. You may have noticed that when the tool was running, let me start it up again so you can see exactly what I'm talking about. The line that I'm currently dragging is white, and when I click, it turns purple, and we get another white line, etc., etc. So I'm basically using the ability to track those objects over time to control their behaviors as the tool runs and make it a little bit easier to manage your geometry visualizations. Okay. And let's see, let's dip a little bit into JavaScript and take a look at how we actually develop that, that area patrol mode for a moment. So when we actually are doing the area patrol mode, one of the things we want to do is when we have completed the entire circuit with our lines, we want to convert that into a navigation modifier volume. So let's take a look at where that happens. So here in the behaviors terminate, we actually have this build nav volume node, and we'll just take a peek at that. So when we're actually doing this, what we want to do is we're actually going to start with a dynamic mesh actor. So this is some geometry script again. And we're going to take that dynamic mesh actor and we're going to use a extrude polygon node on that and take all the points that we drew out during the tool's operation and make it into a polygon on the surface. Then we're going to pull it up into a prism and convert that polygon then into, over here, a new volume. And this is what's allowing us, by setting it to a nav modifier volume class, to basically on the fly construct navigation modifiers for our scene that allow us to control where all these NPCs are going to be moving around. And that's basically, it's a pretty nice, short, sweet piece of geometry script that lets you build navigation changes on the fly. And I think it's a nice use of Scriptable tools. Okay, let's see, how are we doing for time? We've got 20 minutes left. So I think the last tool I wanted to show off today, you may not be expecting it, but this dungeon itself is not actually a static mesh. This dungeon is actually a PCG graph that's rendering it all out. And it's actually being controlled over here by this dungeon actor object. So let's take a look at what that looks like. Let me pull this over. It's not very impressive, actually. You may have been expecting more. There's nothing really here. There's a couple of functions to rebuild it and clear it out, and then there's some arrays. So that's it. It's just some arrays and a PCG graph. It's pretty bare bones. The PCG graph is a little bit more impressive. I'm not going to actually go over that because this isn't a PCG talk, but I'm happy to answer questions about it later. This is basically taking those arrays of information and building out a dungeon from it on the fly. And you can see that here as I take our graph and zoom in on it here. We can actually go and let's just turn this off. And now you can see we have debug volumes going in, which is making everything look really wonderful. Let's turn that off because that looks crazy. So this dungeon is being generated on the fly. But the real interesting part is where the data for this dungeon is coming from. And that's a scriptable tool. In fact, this dungeon was built on the fly in editor with scriptable tools with this final tool that I've got here called layout. And it's really cool because if I have the dungeon selected like it is now and I start layout, the dungeon goes away. And the whole thing becomes something that I can just go over here and draw out, new rooms of the dungeon. And look at that, we've got dungeon. And I accept it. And a couple seconds, takes a little bit for it to happen. And then PCG will come in and just fill in all the gaps. And give us all of the meshes that we need to have our dungeon look really cool. So that's fun. And even better, if we don't have the dungeon selected, we just have something else selected and we start layout, we get to start a new dungeon from scratch. Over here, we can fill in a little bit of a space and do a hallway. It's kind of picky though. The tool wants you to have an entrance and an exit because, well, you always have to be able to get in and out of your dungeon somehow. But once you do that, you can accept it and look at that. We have a second dungeon. Totally separate object. So how did we actually pull that little trick off? So that's why I'm going to talk about tool builders here for a little bit. So if we take a look at the, now I'm running out of windows. I have so many windows open now. If you take a look at the dungeon layout tool here, you'll notice that we have on the side this, no, that's kind of off the screen a little bit. That's all right. It'll be okay. We have here at the bottom a tool startup requirements field. And this can be a couple of different options here. We have none, tool target, and custom. These basically are choosing how the tool is going to start up. By default, all the tools you've seen so far in this talk have been none, meaning that we can start them anytime, it doesn't matter what conditions are. But we can also use a tool target or custom blueprint class to determine whether or not something should start. So this one's actually set to custom, and I've got it here to a dungeon layout builder. And that's what this class is over here. And if you take a look at what one of these tool builders has, the custom builder has two different routines in it. The can build tool and the on setup tool. For our purposes, actually, this is a pretty boring example because the can build tool is always on, meaning we want to be able to start whenever, we want to be able to start when we have dungeon selected or not dungeon selected, etc. But for the purposes of a demonstration, I can turn this off here. And if I recompile this, you'll notice that our dungeon tool goes to gray because we are now telling the mode that no, at this point in time, you can't actually start this tool for whatever reason. And the reason being I clicked off the checkbox, but you could put in some more interesting logic there if you want to. The important thing to note though is the custom tool builder class does run on tick, so there's it's sort of a double-edged sword in terms of power here. If you put a lot of custom logic in there and it's really expensive, yeah, you might feel that in your editor because it's going to be running all the time to see if tools can start. The other option would be the tool target custom builder, and that one is a lot more efficient, but it's also a lot more restrictive because it's based on tool targets, which are pre-existing basically filter classes that are written in C++, and there's not too many of them out there at the moment. We have them for dynamic mesh, static mesh, skeletal mesh, that sort of thing. You can write your own, of course, but at the moment we don't have too many built in. But the other thing it lets us do is when the tool starts up, we have this on setup tool. And this runs before your setup routine and basically lets you do pre-setup initialization. In our case, what we're going to do is we're going to take a look at what the user's selected over here, which is, in our case, the dungeon actor. And we're going to see if we have one of those. And if we do, we're just going to pass it down to the tool as your startup options. And this basically lets the tool come in with object information already preloaded into it. Let me actually go back and make our thing actually run again so we can play with it. There we go. so we can actually go in and do things like this, where we have this sort of smart object that interacts with the tool and sort of acts as a way to save state when the tool is not running. This is all, of course, custom. I mean, I wrote this for the demo, but as you can see, it's not too difficult to pull something like that off if you wanted to have a tool and an object work together in concert during your level design. Yeah, so let's see. The last thing. Last thing I want to talk about is the tool groups. I mentioned at the beginning of the talk, and we'll use the dungeon layout generator to point at these. You'll see down here at the bottom, we've got this group tags option. We've got a couple of tags in here. And these tags are classes. So if we take a look in our content browser, we can see we've got this groups folder. And it's got a bunch of different group classes in here. And these are all pretty simple blueprints. They just have a string. But the point is that they're assets, and the system is able to find all of those and uses them to populate this list up here to determine what groups you actually have in the editor at any one time. And as you click on these, you can actually filter which are going to be shown in your mode. You can combine them together to create whatever custom combination you want. And this is really useful, again, if you have like a large team and you want to be able to have lots of different tools and you don't want to have them all show up like from your rendering group and from your level design group and whatnot. You want to be able to separate things out a little bit. And yeah, that's basically what I have to show you here today. I really appreciate everyone coming so late in the conference to listen to me. Hopefully this wasn't too boring and was interesting and exciting. I'm happy to take questions. We've got about 13 minutes left, so I went kind of fast, but I'm happy to answer what I can. Thank you.